maybe a good place to start for our audience is just to review those four classes of molecules that are critical to making life as we know it.
Okay, there are the four classes of molecules. One is sugars, which are called carbohydrates or saccharides. It's all the same thing. Sugars, carbohydrates, saccharides, all the same thing. And the polymers made from those. And so that's one class based on the sugars. Another class is based on amino acids that polymerize to your proteins and your enzymes. So that's the second class that are based on amino acids. The third one is based on nucleotides, which are a sugar with a base, and a base meaning that it's a nitrogen-containing compound, and a phosphate group hanging off, and that's what makes up the DNA and the RNA. And then you have the lipids, which make up a lot of the bilayer, the surrounding, the shell of the cell, and the shell of the organelles that might be in the cell if you had a eukaryotic cell. Prokaryotes.
That's excellent.
Again,
so those are
those are the four classes.
Four classes, and so at a macro molecular level, you have the sugars, you have the proteins or enzymes, you have the nucleic acids, DNA and RNA, and then you have the lipids. And so you can't get anywhere if you can't build those molecules. And as I understand it, a big part of your critique has been that the undirected chemistry from smaller inorganic molecules does not spontaneously move in the direction of any of those life-relevant molecules. Is that in the broadest sense the problem that you're identifying?
Right. So in the broadest sense, if you use directed chemistry that's prebiotically relevant, meaning that you're using chemicals that would have been available on a prebiotic Earth, so nothing that's been human designed, complex human designed, you're just using basic chemicals and what Steve Benner would call hands-off chemistry, where you're putting minimal input chemistry into it, you can't make any of these compounds that are in any state usable. You might make a trace of them in a sea of other molecules where you have much, much less than 1%. And so it becomes impossible to use it because it's already filled up with other molecules in it. What Lee Cronin does is he makes inorganic complexes which have nothing to do with any of the four classes of chemicals, like zero to do with any of the four classes of chemicals. So that's the problem with his first paper, which he said was mind-blowing, but it's actually utterly ridiculous. And that's what I show in my video. It's a bunch of nonsense.
And apparently irrelevant, because he's not building the chemicals that are actually present in living systems.
Correct. And he has no way of even projecting how that chemical would ever be relevant for any sort of living system. So it's just ridiculous, and it's amazing that the community, the Origin of Life community itself, didn't just fall over laughing when he made this relation to Origin of Life, which doesn't constitute the majority of his paper. The majority of his paper is very interesting chemistry. It's when he makes the relation to an Origin of Life type scenario. And so this is just a bunch of nonsense. And then he says there's this element, molybdenum, is like almost as abundant as iron, not as abundant as iron, but he has no reason to believe that this wouldn't work with iron. What is he talking about? This had nothing to do with a bunch of rust and iron oxide. He even refers to it as rust because it's a bunch of metal oxide. It has nothing to do with life. Nothing. And and he knows what life is, because he has videos where he's even said where you've got to have a cell. You've got to have homeostasis, where you have this internal working state. You got to be able to pass information on to offspring. He understands what life is, but then he makes a bunch of junk and he says, this is suggestive of life. That's the problem. Now, Lee's a nice guy, but it's because of him that people are so misled in this whole area of Origin of Life, where they think that it's already been solved.
You cite an interesting statistic, too, about how many people think that scientists have been able to mix molecules together in laboratories to produce single-celled life forms, such as bacteria. How many people, what percentage of the public believes that?
2/3. Over two-thirds of the percentage feel that think that scientists have made bacteria. mixed chemicals together to make simple single-cell organisms like bacteria. And this is totally untrue. In fact, 1/3 of the population thinks that scientists have made simple organisms, simple animals like frogs in the laboratory. This is so far from the truth. And it's because of this loose talk of people like Lee Cronin, these sorts of experts, their loose talk in what they say, that it leads to this type of thing.
Well, let's talk about some more of the more specific scientific results that he's touted. We've talked about his ideas about autocatalysis and your explanation of why those are not relevant to explaining the origin of life. But he also has done some work on the Formos reaction, which is a reaction, as I understand it, that produces sugars and therefore could be conceivably relevant to prebiotic chemistry, because that is one of the 4 classes of molecules that need to be produced. What does he claim about this reaction, the Formos reaction, and what has he demonstrated in the laboratory about the plausibility of generating sugars through this reaction under prebiotic conditions?
So he takes some simple organic chemicals and lets it undergo a Formos reaction, and he himself even says that in seconds to hours, you get billions of different products. This is totally contrary to what Dave Farina teaches, and Dave didn't even know it. Dave, in the same video...
Hey, Jim, just before you go into that more, could you, just for our audience, explain in general terms what the Formos reaction is?
Formos reaction is to take a simple aldehyde, a compound that has a carbon to a double bonded to an oxygen, along with an alcohol, and you polymerize these into the structure of carbohydrates, of sugars.
And are these 2 starting molecules inorganic or organic?
They're organic. So you can take simple organic compound and polymerize it. So it has an alcohol on it. It has an aldehyde on it, and you mix it. He mixes it with calcium hydroxide. Now, interestingly, in the very same video, Dave goes on to say that calcium hydroxide is irrelevant because it's too strong a base to really be widely available on an early Earth. He concedes that it's available. He wants to dismiss calcium oxide, but his expert comes on and uses calcium hydroxide, and he didn't even notice it. He put up a paper with Lee Cronin's work showing calcium hydroxide, and Dave didn't even notice it. So the poor man cannot even see calcium hydroxide in that paper. He doesn't even realize. And in fact, he cited another paper in his critique that also had calcium hydroxide. Even his own slide showed calcium hydroxide, and he said it was not relevant. And then when he later brought on Steve Benner, he used calcium hydroxide, and Dave didn't even notice it. So we're talking about a man who is utterly clueless on the topic of chemistry, trying to teach chemistry. Put Dave aside, now we're dealing with his so-called expert, Lee Cronin. So
what is Lee's claim about the Formos reaction and how it could have occurred on the early Earth, and what he's getting out of his simulation of that?
So what Lee does is he tries to do the Formos reaction, but he keeps dumping in more and more of the starting material. And he says as it goes through these recursive cycles, it cleans itself up. It starts clean, you get less compounds. So in other words, you initially get billions of compounds, but he makes it less billions by somehow cleaning it up.
And the billions are a problem because you don't want lots and lots of things besides the sugars. You just want the sugars that are life relevant. If you have a lot of other byproducts, they're going to interact with each other, and you're going to move in a life unfriendly direction. Having lots of things is a problem, not a good thing, right?
Right. You actually gum up the works. That's why chemists in a laboratory will work very hard to minimize the number of byproducts. This is what you spend most of your time on, trying to minimize the number of byproducts and maximize the compound that you want. And so what Lee does is he gets billions and billions of compounds. He can see, say, 1,000 of those, because under those 1,000 dots or spots, there's many others under there that he can't detect because they all co-elute. They all come overlapping with each other. And And then he dumps in more and more material going through these recursive cycles. And he says, you see, I'm getting less dots here. I'm getting less compounds. That's not the case, because if you read his experimental literature, the experimental, which Dave never read, he says that he takes off 70% of the supernatant, the things that are floating in the solution, it's suspended in the solution, and the things that are precipitating out fall out of the solution, and he doesn't use those. So in other words, the reason he gets less material is because these compounds are polymerizing, they're falling out, and he's only skimming off the top. So of course
he's skimming essentially the waste byproducts out of the resulting system, and then that allows him to concentrate the one thing he's looking for, and to get fewer interfering.
Right. But not the one thing. He's concentrating maybe 100 billion things into 99 billion things.
Okay.
So
he really hasn't solved the problem. He's only made it minimally less destructive.
Because he cut out 30% of his solution. If you cut out 30% of the products that precipitate it out, yeah, you're going to clean it up. And the more times you do that, but you have to keep adding.
So this is not a naturally recursive system. This is an intelligently intervened. He's intelligently intervening to clean things up so that he's gradually purifying his reaction product.
I think you're being very kind by even saying that this is an intelligent method. It is not an intelligent method. You are speaking of intelligence as adding some user input into the system, but it's too flattering of a word, Steve. It's too flattering of a word for what's being done here. So there's nothing intelligent about this. He's just letting the polymers crash out, and then he has to keep adding in more and more starting material. Where do you get boatloads of more and more starting material to start dumping into this? Pure starting material you dump in. And then he gets out so many products, he can't even analyze which isomer he's got. And then he says, well, we have identified a compound that looks like ribose, but I'm telling you, the man has billions of compounds in there. That would be totally unusable. Did he ever use the ribose for anything? No. Why not? Because he can't separate that ribose from anything. You can't even separate it, even with the most advanced techniques that we have today. He used something that was called ultra high pressure liquid chromatography, liquid chromatography, which is the most complex method we have to separate compounds in an analytical, not a preparative column, but an analytical, meaning you get traces of the material. He couldn't even separate it out. He even
if you don't separate it out, you're going to get interfering cross reactions that are going to create sludge that have nothing to do with life. That's
exactly. Yeah. It doesn't do anything. And Lee understands this because he has other videos where he says you might find one molecule of something in interstellar space that might be life relevant, but it's not good for anything because it's mixed in with many other molecules. So he understands this.
He understands the problem.
Yes, he understands the problem. Yet he
I have a
goes
quote
ahead
from
and
him
makes
here,
this.
Jim. He says, all the people that have made life in the lab have cheated.
Yes.
So he first of all, we haven't made life in the lab. That's absurd. All the people who have made life-friendly chemicals in the lab, I suppose he could say. But he acknowledges the cheating, but not about his own work? What's going on?
Right. So he said all the people who have made life in the lab have cheated because they've used molecules that have come from naturally occurring cellular sources. Number one, even if you use molecules that come from cellular sources, they've never made life in the lab. So he has a lot of loose talk that confuses society. Nobody's made life in the lab. And so, as you know, on my video series, that I really drive that point home, that his loose talk, he's responsible for people thinking that people have made life in the lab because he went around saying it. And he understands the magnitude of the problem. He's nowhere close. He said in 2011 that he'd make life in his lab in 2 years. And he didn't, it's 2 years past 2011. I mean, we're 11 years, almost 12 years past 2011. And he hasn't yet done it. So this is such loose talk that he comes out with. And why should Lee Cronin be surprised that Jim Tour is reacting to this? Everybody should react to this. Any chemist would react to this if they followed this work. Nobody's made life in the lab. The junk that he made in that foremost reaction is utter junk. It's not useful for anything. It's no good.